Listen, if you're just sitting there memorizing textbook definitions for energy and power right now, stop. Your standard revision is literally a complete waste of time. You're studying to remember facts, but Cambridge examiners, they are grading you on how you think.
Look at this student calculation, pulled straight from a mock exam. Power equals 500 divided by 2, which gives 250. Now, on the surface, sure, the math is spot on. But in a Cambridge 0625 physics exam, this is a totally fatal error. It's completely missing units. And honestly, worse than that, there's no formula shown, so we don't even know if they used the right variables in the first place.
And because of that, 0. 0 is exactly the number of marks awarded here. Yep, no way around it, just a 0. You don't even get a compensatory mark for doing the division correctly. Students make these devastatingly simple errors on their Cambridge exams every single year, and they lose whole grade boundaries, not because they don't get the physics, but simply because they don't know how to write it down.
Okay, let's dive into this. These are the silent traps examiners see constantly. Missing units, rounding your numbers way too early in multi-step calculations, writing these super vague explanations about energy just moving instead of specifying the actual stores, swapping out the wrong variables, misreading an inverted graph axis, or giving really weak improvements for practical experiments. These are the exact pitfalls draining your marks.
Section 1, the examiner's secret framework. Stop memorizing, start thinking.
All right, so it's time to shift our whole approach. We need to use mark scheme thinking. See, examiners aren't hunting for just a general vibe that you get the topic. They're looking for specific triggers. And to give them those triggers, you've got to use this exact 4-step framework for every single written answer. Step 1, state the concept. What's the underlying physics principle? Step 2, evidence or data. Pull the exact numbers or observations straight from the source material or diagram. Step 3, scientific reasoning. Actually connect that data to the concept. And finally, step 4, examiner wording. Wrap the whole thing up using the exact correct physics terminology.
Now, in a moment, I'm going to show you the one examiner clue that completely changes an efficiency answer. It's literally the exact step where top students accidentally throw away their final marks. But first, you need to see this framework in action so that clue becomes incredibly obvious when we finally get to it.
Section 2, spot the physics error. Pause and predict.
Let's test your mark scheme thinking right now with a quick pause and predict moment. Take a look at this flawed student answer. The energy transferred is 400. Go ahead, seriously, pause for a second. What's missing here? Why does this immediately make a Cambridge examiner reach for their red pen?
Well, the absolutely crucial point is that 400 means absolutely nothing in physics without a unit. I mean, is it 400 apples, 400 seconds? No way, it needs to be 400 joules. And on top of that, energy transferred is just way too vague. To actually lock in those method marks, you must specify the energy stores. You've got to say something like 400 joules of energy is transferred from the kinetic energy store to the thermal energy store. That level of precision is exactly what locks in your grade.
Section 3, anatomy of a top answer, locking in full marks.
Let's break down the anatomy of a top band answer to see exactly how to secure full points. It all starts with the foundational concept. For anything in this topic, the reigning concept is the conservation of energy, which states that energy cannot be created or destroyed, only transferred between stores. Actually stating this correct physics terminology right out of the gate, that signals to the examiner that you know exactly which rules govern the system you're analyzing. Now, what's really interesting about this is how perfectly this data is organized to prevent that wrong variables mistake we talked about earlier. Look at energy and work. They both share the exact same unit, joules. Work done is really just a measure of energy transferred. But power? Power is watts. Power is the rate at which that energy is transferred over time in seconds. If you mix these up, well, your scientific reasoning completely collapses.
Let's look at a quick comparison here. A flawed answer says, power is fast work. I mean, it's colloquial, it's vague, it's kind of how you might talk to a friend, right? But the improved, top-band Cambridge-style answer says, power is the rate of doing work, calculated as work done in joules divided by time in seconds. This explicitly uses our framework, concept, reasoning, and that exact examiner wording.
And this brilliantly illustrates exactly what the examiners themselves tell us. According to the official grading guidance, a strong answer should include correct terminology, substituted values with units where needed, and exam-safe wording. So that improved answer we just saw, it didn't just casually describe power. It presented a mathematically and scientifically rigid definition that literally forces the grader to give you the mark. All right, let's move on and see how this builds to that clue I mentioned earlier, 100. This is the absolute magic number for efficiency calculations because, efficiency is useful energy output divided by total energy input. But to get the percentage, you must multiply by 100. And here's the massive trap. Students do the division, they get a long decimal, they round it immediately, and then they multiply by 100. Actually, that early rounding completely cascades through the whole calculation. It makes your final percentage slightly off, and bam, the examiner docks your final accuracy mark. So always, always keep the full value in your calculator until the very last step.
Section 4. The mandatory next step, beyond the calculations. So, you now have the framework to totally crush calculation and explanation questions. But honestly, that's only half the battle. Cambridge exams love to follow up a calculation with a practical investigation or a data analysis question. And this is where entirely different traps are just lying in wait for you. I mean, what happens when you turn the page and face a graph where the y and x axes are inverted from what you normally study? Or when you're asked to evaluate a conclusion that the data actually contradicts? If you don't know how to spot those graph axis errors or how to write strong, safe practical improvements, all that math we just perfected, it won't save your overall score.
You absolutely cannot afford to lose those final grade boundaries on weak data analysis. What to revise instead is in Explainer B. Uncovering those linked practical and data analysis traps is your absolute mandatory next step. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and click the explainer on your screen right now to seamlessly lock in the rest of your physics marks. I'll see you over there.